Okay, so now we're going to talk about what are called inscribed angles. So first of all, what is it? So an inscribed angle is an angle with its vertex on the circle and whose sides intersect the circle. So let me just first draw an example here. So an angle with its vertex on the circle whose sides intersect the circle. So something like, got to get a pen here. So something like, if I put the vertex there, or I'm sorry, the one part of the side there, put the vertex there, there we go. That is an inscribed angle because we have the vertex on the circle and the sides are intersecting the circle. So that's an inscribed angle. So, an intercepted arc, let me see if I can go back here. An intercepted arc is the arc formed by the intersection of the two sides of the angle and the circle. So if I'm looking at my example here, the intercepted arc, very similar to the intercepted arc really for the central angle, same idea. In my diagram, this would be the intercepted arc of the inscribed angle. So if I called, if I called that A and that B and this C, my inscribed angle would be angle ACB, and my intercepted arc would be arc AB. Okay. So that's what an inscribed angle is, what it looks like. Now, we get to the inscribed angle theorem. So there actually is a theorem that talks about the inscribed angle. And what it says is the measure of the inscribed angle is half the measure of its intercepted arc. Half. Okay, so the inscribed angle, if I'm looking at this example, angle ADB, that has measure that's half of the intercepted arc. So we see the intercepted arc is arc AB. If I take half of 118, I'll get the inscribed angle measure. So 118 divided by 2 would give me 59 degrees. So the measure of angle ADB, which is an inscribed angle, is 59 degrees, half of 118, the intercepted arc. So let's take a look at the next couple examples. So if I see the inscribed angle and I want the intercepted arc, so now remember we know the angle and we want the arc rather than the last one we knew the arc and we wanted the angle. 41 degrees, the angle there is an inscribed angle, so I'm going to double that, of course, to get the intercepted arc, and when I double 41, I of course am getting 82 degrees. Let's look at the next one. So remember, we already talked about central angles being the same or having the same measure, being congruent. So if I see that this angle in the dotted line or dotted lines is marked 56 degrees, that's a central angle. So central angle has the same measure as the intercepted arc, which means I know that the intercepted arc here marked X is going to have measure 56 degrees. Okay, so that's how we figure that one out. using what we knew from before. But now we also want to figure out the inscribed angle here marked y. So remember, that's half the measure of the intercepted arc. So I'm going to divide 56 in half. Well, 50 in half would be 25, and 6 divided by 2 is 3. So that's going to be 28. The measure of angle y is equal to 28 degrees. Let's take a look at the next one, or the next couple. So this time I'm seeing a circle or a triangle inside the circle. So I can see that if I follow this inscribed angle, and this often helps to do this because sometimes it's hard to see. If I start at the vertex of the inscribed angle and I follow its sides out, that leads me here and here. That leads me to arc Y, this intercepted arc. Okay, so I'm going to do the same thing we did on the last several. I'm going to double 78 to get the intercepted arc measure. So 78 doubled gives me 156. So, whoops, it's not writing very well. 156 degrees is the measure of arc Y. So I'm going to do the same thing to get the other two. I'm going to look at arc X. So arc X, see if I can highlight this with a different color. Arc X starts there and ends there. So I can see that that is a semicircle, okay? And I can see that because it lines up with this 90-degree angle. That's the inscribed angle that meets up with the intercepted arc, or intercepts the arc. So 90 doubled is 180 degrees. 180 degrees. Okay, now I want to get that last piece, arc Z, and there are a couple ways I could do that. I could either just focus on the two arcs that I know, 180 degrees and 156 degrees, and I know that they should total 360 degrees for a circle. So I could add 180 and 156 and then subtract from 360. So let's look at that. So 180 and 156 added together gives me 336, and 360 minus 336 is 24 degrees. So that's one way to get Z. Excuse me. The other way we could get Z is by using the inscribed angle. This one that's created here with this purple side, and it was red, but I'm about to make it purple. So that angle right there creates that intercepted arc right there. So I could get that angle by adding the 90 and the 78, subtracting from 180 because there's a triangle there, and getting that angle, which would be 12. And then doubling 12 to get Z, which is 24. Okay, now I think that would be a little bit more work, but we could do that if we had to. All right, let's take a look at the next example. So first of all, I'm seeing a central angle here at X, point X. So I know that central angles have the same measure as the intercepted arc. So that means X is 114 degrees. I'm also noticing, though, that we have an inscribed angle. So it starts here and it ends here. okay, which means the intercepted arc is that 114. Okay, so if the intercepted arc is 114, we know that that's double the inscribed angle, so I'm going to divide 114 in half. So when I divide 110 in half, I'm getting 55, and I'm going to add 2 more to that, so 57, because half of 4 is 2. So 57 degrees is uh, the angle that's marked Y. Let's look at one more. So I can see that we have 2 inscribed angles here. We have this one here that's marked 28, and the intercepted arc is arc X. So I'm going to take 28 and double it, and that gives me 56. But I'm also noticing that we have a second inscribed angle that's marked Y, and it shares that intercepted arc. It has the exact same intercepted arc. So I can see that Y is also going to be 28 degrees, because again, if I take the arc 56 degrees and I divide it in half, I would get the inscribed angle, which is 28 degrees. So whenever you have something like this where you have 2 inscribed angles that share the same intercepted arc, then those 2 inscribed angles will have the same measure or be congruent. Okay, so I think we sort of already have talked about this, but let's just make sure. So if we have a semicircle, okay, if I see that this intercepted arc is a semicircle, it's 180 degrees, then that automatically means that the inscribed angle, that's half of it, is going to be a right angle. Okay, so that the measure of that angle would be 90 degrees. So find the measure of arc ABC. Well, this time we have the opposite. So they're giving us an inscribed angle, and we want to find the measure of arc ABC. So I just double 90 and I get 180 degrees. So what that should be showing you is that anytime you have a semicircle, its inscribed angle is going to have a measure of 90 degrees, or it's going to be a right angle. And anytime you have a right angle that's inscribed, its intercepted arc will have measure 180 degrees, meaning it'll be a semicircle. That's it for now on inscribed angles.